Hello, everyone. Welcome to this first Cloud Builders meetup, which we have everyone remotely. Well, I'm from Norway. There will be another guy from Norway, and I know a lot of people watching from all over Europe and actually abroad, like abroad, where it is soon going to be night. So today I'm going to be a moderator, and it's my pleasure to be a moderator and talk to so many interesting people who I know in personal life. And let me introduce myself for a brief second. My name is Anton Babenko, and I'm AWS community hero as well as Azure hero, and I'm actually CEO of Betajob. This is a company where I am pretty much the only employee, to be honest, but anyway, I like to work with technologies. So today we're going to have several speakers from different big companies, big companies, not like Betajob, but big companies. Well, no, first let's talk about what this meetup is about. This meetup is about community of people who likes to build different cloud technologies. And this is our first meetup. Well, as you know what's going on in the world, that's why it is online. And it's a really good situation to be, because it's easier to get a lot of people from all around the world to spend 1 or 2 hours to listen to experts in industry. So today we will start the meetup with the talk by Paul Czarkowski, who will be talking about be the platform you want to see in the world. Then after this talk, there will be Q&A session where you, like yes, you and you and you, can ask question. So please use YouTube chat window to write your question, and then me or someone else will find these questions and we will read them to Paul. Then after this, we'll have Roman Pavlyuk, who is VP, and he is VP of technology, at Intellias, and he will shortly talk about trends in the industry so that we all understand what's going on, right? It's something going on. Anyway, after that, there will be two excellent speakers from AWS and from Microsoft, and it will be my pleasure to ask them questions, which I have prepared. But actually, I'm really looking forward to get more questions, because I'm sure that these experts will be glad if we ask them tricky questions, or your questions, or maybe something what you're curious about what's going on in AWS or in Microsoft. The first speaker will be Sergey Pugachev. He is solution architect at AWS. And the second speaker will be Shailendra Singh Chauhan, who is global cloud architect at Microsoft. So this meetup itself is about you and your problems and what you want to learn in terms of cloud technologies. So please don't hesitate to come up with questions, with problems. This is so-called BYOP, bring your own problems. And let's discuss. Without several companies and without several sponsors and supporters, this meetup wouldn't be possible. So please do small thing. First, you can subscribe to our Telegram channel and YouTube channel, because this is just the first meetup which we are organizing. Hopefully we will have more meetups with more speakers. So stay tuned and subscribe to our Telegram channel, YouTube channel, as you can see in the description to this stream on YouTube. And without further delay, let me introduce our first speaker of the meetup, who's going to be Paul Czarkowski. And let's see what Paul has for us.
Welcome, everyone. Unfortunately, we're not all in the same room doing this together in person. So my name is Paul Czarkowski, and I'm a developer advocate at VMware. And the question posed to us for this event was, how would you build it? And I took that actually to mean, how would you build IT? Because I think that's really the heart of the question. If we build out IT right, if we build out operations right, the rest will follow. So operations is the secret sauce to writing good software. If you look at the big folks, the FANG, Facebook, Apple, Google, Netflix, etc., they all have this common characteristic. They constantly deploy to production. They can go from writing a piece of software, it's a piece of code, a small little feature, to having it running in production in a time frame that is measured not in hours, but in minutes. That ability is a competitive advantage in this world in which every company is a software company. If you can get code to production faster than your competitors, you have an unfair advantage over your competitors. The more frequently you can deploy software into production, the better quality that software is going to be. But in order to do this, we need to move on from traditional operations. Automation helps get us along the journey for sure, but codifying your existing practices can only speed things up by so much, because there'll still be toil, human capital, legacy processes built on top, especially at a larger org where you've got years and years of tradition in ITIL and similar process-heavy systems. If you have a change control board, if you are forced to use deployment windows, you are currently being beaten by somebody who has moved on from those things. This here is a survey result from Forrester, and it was talking about how often you release software, and this is done over time. And what this shows us is that we haven't really improved much over the last few years. We had some improvement up to the point where we got to like once a quarter or once a month. That's where about 50% of the respondents are sitting on this. And then we kind of stagnated. You can see those peaks match up year over year. This is not good enough. There's only 2 or 3% that are releasing daily. We need to get better. And how do we get better? Well, I'm not sure if there's a way for a company to go directly from that old school ITIL type model to doing what I call cloud native operations. Most organizations need to make a transition. And there are a few steps to get there. Trying to change everything at once is a recipe for disaster. A recipe for a failure that ensures it will just revert back to our previous behaviors because they were safe. So let's kind of hit some key points of this transformation. So many orgs are still at this point, right? Everything is waterfall, it's planned out years in advance, and it's just this slow trudge through development through to production. It can take a year or longer to get a business requirement into code and then into production. And many of us still work with companies that act like this today. What usually happens is there's some sort of external stimulus. Something happens and somebody in the organization realizes that it's not good enough anymore. So we hire an agile coach. We send out PMs and we send out developers to Scrum training. And we start doing something that looks like Scrum, or what is Scrum for? We have our sprint cycles, we have our backlogs, and we release code at the end of sprints. But QA and operations are still outside of this process. So we might be delivering code or builds every sprint, but it ends up sitting in this virtual warehouse as idle inventory. So our next step is to bring QA and test into the sprint, right? And we start moving test to the left. We start reshaping these groups to look more like developers, because that's how we solve things as developers. We make things code problems. We start to do things that resemble continuous integration, but it can still take months to get this tested code into production. So we bring ops across. We bring them into our sprint cycles. We rename them to be DevOpses, and we start doing infrastructure as code, ShareForce, Ansible. We're not getting the improvements we hoped or were promised because we're still heavily incented to have zero downtime. We often still have a change control board. We're often still forced to remain inside of deployment windows. We don't deploy on a Friday. We don't release code often enough to get good at releasing code, and therefore we never trust ourselves to do it regularly. Part of the reason we're here is because we're locked into Conway's law. The structure of the software will mirror the structure of the org that built it. I'm not talking about just the org of the software development part, but operations as well, QA as well, your entire organization. So we need to hack Conway's law. We need to make Conway's law work for us, not work against us. We need to change. So this is traditional operations, right? We've all been here. We've all done this job. You sit there, you look at a Jira queue, tasks come in, and you perform work. Sometimes that work is done through automation, through Chef or Puppet or something. More often than not, it is done via SSHing into servers. This is what a platform looks like. Whether it's Amazon, whether it's Kubernetes, whether it's Heroku, they also have this same basic architecture. And it's the same thing, right? You've just replaced Jira with an API, and you've replaced your sysadmins with automation. So your ops team is a platform. It's just a really highly inefficient platform made out of meat. Don't be a meat cloud. So if we acknowledge the fact that operations is a platform, then we can treat it the same way we treat platforms, as a product, with users, the developers, the people that want to run software. To do this, to build a platform as a product, we build out teams to build and run the platform in the same way we would build and run any other product. We turn our operations team into infrastructure teams and platform teams. And these teams are responsible for building up the platform for your applications teams to use to deploy their software. These teams should determine at what abstraction layer does it make sense for them to build this platform on, and then find somebody else to provide up to that layer. Find somebody else who's an expert in those things. Just like we have app teams that focus on specific parts, microservices of a product, we do the same for our platform. Small teams that build platform services and then contracts for utilizing those services are composed together to create a cohesive platform, just like we compose microservices together to create a cohesive application. And these teams are multidisciplinary. We have product owners, developers, operations, QA, etc. So our jobs aren't going away, they're just changing, and we need to change with them. And as small teams iterating on a problem, you're going to make lots of small bets with small wins and small losses, but they'll accumulate into one big win rather than having one big bet that's more likely not to fail and have us back to our old safe ways. As a platform team, we're building up this paved road for our developers to travel on. And as long as they stay on this paved road, they should get access to these platform services, monitoring, observability, access control, certificate and secret management, etc. And this gives your feature teams, product teams, a place to deploy their applications with minimal toil and maximum value. You don't want to become their only choice. You want to be their best choice. You want them to want to use your platform because you're offering these things. Effectively, you need to fill in this picture to provide the code delivery pipelines to take committed source code from development through to production with minimal human gates and checks. You have to fill in this picture with all the bits and pieces required to make this happen. This is what I call cloud native operations, treating operations as a platform, as a product. Taking lessons from cloud native software development techniques and architecture, we're reimagining how we're doing operations. In a way, we're playing catch up to what Netflix and others did 5+ years ago, and that's okay because we're not Netflix. You don't need to be doing capital D DevOps to do this, but you do need to be doing DevOps. Because we were doing this stuff before DevOps. They were doing DevOps, didn't call it that. This is from 2009 and is like the prototypical DevOps talk, but it is definitely not capital D DevOps because it preceded DevOps. This is 2009. And they nailed it. If you go back and look at this talk, everything you see in DevOps is captured in this talk. If you go back and read the OG Continuous Delivery book by Jez and David, you'll see a lot of concepts that we're talking about right now neatly laid out with examples showing tools like Jenkins, although it was probably Hudson at the time, and Puppet. There's plenty of ways, many ways to build out this platform, even if you're deploying to bare metal. I mean, IPMI, Pixie, it's a beast, but it is tameable. But I hope that we've all moved on from bare metal. Hopefully none of us think it's a good idea to be spinning Rust, unless of course that is the core part of our business model. Hopefully we have access to a modern infrastructure platform being run by the experts at that platform. A platform like Kubernetes. Now, you do not need Kubernetes to build your operations team, to build your platform on. Again, Netflix, they didn't have Kubernetes. They might do now, but they certainly didn't when they built their original infrastructure. But Kubernetes does have a lot of important and useful concepts that can make it a perfect place to start. We do have to be careful. Maybe asking everyone to write YAML deployment manifests is still too much. If you're happy to continue with our wall of confusion model, albeit a wall of YAML, we'd still be hitting that deployment bottleneck. Maybe this is going to be a vast improvement where you're at now. So this might be another stepping stone on your way to a real platform. Now, the underlying magic of Kubernetes is not that it's a container orchestrator. I could care less about the packaging and deployment mechanism of containers. The magic of Kubernetes is in its controllers. They are reconciliation loops. There's a declarative API that takes your desired outcome and then applies logic through these controllers to make that outcome reality. And then it continues to ensure that remains the case. You don't give instructions to Kubernetes. You tell it what you need. These controllers are powerful, and it's not that difficult to write your own. I have written my own controllers, and I am the furthest thing from a software developer you can be. Kubernetes even have custom resource definitions that let you extend the Kubernetes API to support your own custom resources. By utilizing Kubernetes and our own custom controllers, we turn Kubernetes into an API for doing operations, an API for reducing toil. Thinking of Kubernetes in this way helps you do cloud native operations. Let's have a quick look at some examples. Every web application needs DNS. As an ops group in IT, we tend to get a lot of tickets requesting DNS record changes, additions, deletions. Many operations teams are managing DNS by hand on a bunch of bind servers. Maybe they have a chef recipe, or maybe they're clicking around in like Route 53 or similar. Maybe they're really advanced and they have Terraform to do it. But there's still human work and human toil involved in that. Kubernetes has this thing called the external DNS controller. And this controller will watch Kubernetes resources such as services and ingresses. And then based on annotations or other hints provided in the manifest, it will automatically go out and register DNS for the load balancer for your application, which it's also managing inside of Kubernetes. Just like that, no more tickets asking for DNS changes. Every time you deploy a web accessible application to Kubernetes, you automatically get DNS. Here's another example. How many times have we seen outages because of expired certificates? A lot. Sometimes it even makes national news. I worked somewhere where we discovered we had a problem with our infrastructure, an expired certificate, because we saw it on the 6 o'clock news. And that is not a cool way to get notified of an outage. So Kubernetes, we have the certificate manager or operator. It will create and manage Let's Encrypt and other certificates. And it will store them in Kubernetes secrets to be used by ingress endpoints or your application. And just like the external DNS controller, it removes the toil around managing certificates. When tied together with the external DNS controller, you automatically get both DNS and TLS encryption for your applications, again with zero toil. Operators take controllers that step further and allow you to create those custom resources in Kubernetes that can be used by anyone on the cluster. The canonical example is the etcd operator, which allows anyone using Kubernetes to simply say, I need an etcd, and let Kubernetes and the etcd operator figure out how to make that happen. There's a pretty amazing set of operators up on the Operator Framework website, and there's plenty others going out there. Our friends at Pacona, they've built operators for both Pacona with automatic replication, as well as MongoDB, that not only stands up databases, but it backs them up and it restores them. It repairs them when they fail. We have an operator for Google Cloud. So if I need a Google Cloud load balancer or SQL database, I just ask Kubernetes to get one for me, and it figures that out with Google Cloud. The controllers and operators take Kubernetes from being a container orchestrator to being an API for operations, an API for reducing toil, an API for our platform. You can make Kubernetes your control plane for your entire platform, whether it's physical or on the cloud. Once you have an API for your platform, then you have the start of a user experience. But it's about these pipelines, removing the friction from getting code from source into production. So let's start filling that in and actually get that user experience. Boom. Now this is a lot of software, right? That you, the platform teams, have to install and manage. We have observability software, we have CI software, CD software, we have software to store images, to test images for vulnerabilities, lots of stuff. We need to figure that out. And that's okay, because we've just spent 10 years figuring out how to run software. And practices like SRE and GitOps have spun out of DevOps ecosystems, give us really practical ways to implement some of this stuff and make this happen. So from a platform operator perspective, we're deploying our platform tooling on top of Kubernetes using modern techniques like GitOps. And our developers are also deploying their software on top of our platform using modern delivery practices such as GitOps. By using controllers, they get access to DNS certificates. They get access to Google Cloud SQL servers, all this stuff that can be spun up by the platform, not by people. Thank you so much. I hope this has been helpful. Again, my name is Paul Czarkowski, and if we have any questions, now would be a great time.
Great talk, Paul. I really enjoy watching talks about Kubernetes, because for me it always seems like big monster. But you made it sound like it's not as big monster if you treat it properly. In particular, I like the way how you went from Conway law to hacked Conway law to Kubernetes and GitOps. Well, sounds easy, But if we talk about this as let's say small, medium, startup type of company, because according to our research which we made before this meetup, this is primarily the audience which we have today. So I have gathered a few questions for you in this regards. For example, what is the main factor which indicates that the company is better to be using Kubernetes? Is it size of the company, number of application, or something else? Can you talk about this?
Yeah, I think the number of applications is definitely a good indicator. But I would say that like a small to medium company, you probably want to be leaning heavily on the service provider to provide Kubernetes and to provide a lot of the rest of the platform around Kubernetes, right? When you have a platform, whether it's Kubernetes or not, you kind of have three choices. You have an unopinionated platform, you have a platform with somebody else's opinions, and that's usually like GKE or AKS. And then you have the third platform, which is the platform that is built with your opinions. And that last one is where you're talking the larger company that has to have a lot of their own compliance and other stuff, and a lot of pre-built opinions into their company. So I think most folks that are looking at Kubernetes are at that we're talking with are that small and medium, and they're the ones that should be using the ones that Kubernetes from one of the cloud providers or a service provider, and using their ecosystem of tools. Like, you should never have to look at the cloud native foundation landscape horror show of everything involved there, unless you're at that point where you need to build your own opinionated platform, which is probably, thousands of employees, not tens or hundreds.
Right. Yeah, that sounds like my experience as well. Well, another question, which is the follow-up, actually. When you see that the company has started adoption of Kubernetes in runtime, or it's just not great fit for them, what do you usually see as the main struggle for this company? Is it
Usually
led by YAML, or is it something else?
I think usually they're using Kubernetes for the sake of using Kubernetes, not because it solves a problem they have. And so definitely, like, the wall of YAML is a real problem, but it's also that sign that you're using Kubernetes for the sake of Kubernetes, right? So if you're using Kubernetes to solve a real problem, you're probably going to be using it with some sort of deployment tooling you already have. So you're going to, or something that's a fairly simple workflow, like you're going to go the GitOps route and use either one of the vendors that provide GitOps or one of the open source projects that provide GitOps.
Right. Yeah, that sounds so logical according to chat, what people are talking on YouTube right now. Somebody said that Kubernetes is not a monster, but Singh and Pacemaker is a true monster. Well,
that's true. And there's probably a chance that whoever is running your Kubernetes cluster for you is dealing with tools like Singh and Pacemaker, so that you don't have to. And that's why it's important to reach for a cloud provider, someone who is the expert at running Kubernetes or whatever underlying platform you want to use, so that they can deal with all that hard stuff. And you can start at the slightly less hard level of writing YAML files.
Right. I have the last question, actually, which is looking into calendar. We have 2020 right now, and we still have people who are struggling and adopting something wrong. As you are saying that during your talk, it was quite obvious that there are a lot of challenges which people face. Can you tell any alternatives which, again, small, medium, startup type of company should be looking into?
Yeah. Obviously, if you have a few apps, there is nothing wrong with reaching for like the Amazon Elastic Beanstalk and using VMs and baking your own AMIs, that's still a very, like, nothing wrong with doing that. It's still a good way to run software. There's also Nomad is a really good example of like Kubernetes without all the bits you may not need. And then, of course, there's K3S, which is a sort of Kubernetes internal attempt to build something like that, where they've stripped out a lot of the complexity that most people don't need. So you get something that's closer to the container orchestrator without all the extra bits, which often is what someone needs. And like I've seen folks use Nomad, for example, at very small shops, but I've also seen people use it at very large shops with thousands, tens of thousands of containers and applications. So I tend to talk about Kubernetes because it's what I know right now and what I work on right now. But there are so many options out there. So like start with things you know and find out and figure out which platform makes sense based on like the things you already do, the things you already know.
Right. Yeah, pretty clear answer, I would say. There is a question in the chat. The person says, I didn't quite get a part about number of services. Say, if we are a mid-sized company of 50 people with about 70 services, is it a good fit for Kubernetes?
Yeah, I would say that is a really good number of services to be running in Kubernetes. It probably isn't the point where you would be wanting to run your own Kubernetes. So you might be reaching for GKE and using like several GKE clusters across regions. You get some HA, reaching for like Cloud SQL to provide your database backend and stuff, and really utilizing their services so that you don't have to rebuild a lot of that stuff.
Right.
And especially if you're able to deploy your services independently. Unfortunately, a lot of people end up building microliths, which are microservices that they have to treat like monoliths when it comes to deployments and upgrades. And that then becomes quite challenging in Kubernetes or anywhere, really.
Right. Okay. Looks like there are no specific questions from people, at least right now. But I'm quite sure that if you will be able to stick to Zoom call, which we'll have after this meetup, there will be people who would love to ask you lots of questions about Kubernetes in general. So
yeah,
it would
absolutely.
be really good if you can join us. Cool. Thanks again, Paul. Let's switch to another. Hi. Hello again. So, I hope you are still there, because I don't see you, so it's hard to imagine that there are other people on the other side of the screen. And I hope you still like this event. So, it will be fair to say thanks to company who is supporting this. Intellias is a provider of full-cycle software development services with offices in Kyiv, Lvov, Odessa, Kharkiv, Ivano-Frankivsk, and Krakow. And also there is a local presence in Berlin. Intellias has more than 17 years of experience in assembling and managing world-class engineering teams in Eastern Europe. So, by the way, they're hiring senior and middle DevOps engineers. You can find details under this video. So now let's listen to Roman Pavlyuk from Intellias, who is holding VP engineering role in the company.
So hello everyone, do you hear me? I hope you do. So as was the introduction made, my name is Roman Pavlyuk. I'm a VP technology at Intellias, and my goal actually is to developing the excellence program at the company and developing all the high value services that we offer and actually closing this ultimate cycle of resolving client problems, right? So bring your own problem. That's the goal of this meetup as well. So how we work, what we do, and actually how do we respond to those core trends and challenges we have on the market. But let's talk about them first. You know that every company is an IT company now. You heard about this. You also know that like they were pioneers of this cloud movement back in the days. But what's different these days now is that comparing to, for example, mass movement of the startups and technology companies, what's happening to the cloud in, let's say, in 2010, 2015. Now it's different because those old giant enterprises, they start to change as well. And they start to change because there's a growing gap between the IT capabilities and IT operations and their actually business functions. And most of you, or maybe not, but usually that's the reality. Most of you either prefer or you already work with startups, you already work with ISV, which is like a very technology companies and so on, and where you can work with the like state-of-the-art technologies like Google Cloud. I wouldn't say that's very state-of-the-art. I mean, that's now commodity, but like really you can be on the edge. But there are lots of businesses who are just stepping into that area. Yeah, that's true, they are. And they do this slowly because they run the processes that come from 90s with this very old school IT that is, like following the process first instead, or like policy first instead of technology first. They have like a you know they have like a chain attached to their foot, so they cannot move very fast. This and IT unfortunately is playing that role, the role of that chain. So in modern world, there's a huge need of a transformation. And for example, banks that were making money just of giving loans, and they thought like, hey, you have, especially those big ones, because you have no chance. I mean, you either come to them in their physical office, because I either come to their physical office. There was no option. Now you have options when you have just a like all mobile bank. So people open the bank in the app, they install the app, they pass all the verifications and security checks and background checks, not even leaving their home. So you can get like a couple thousand dollars US loan, not even leaving your home, not even like leaving your room. So just all you need is the internet in your phone. And this was a big disruption to the banks. And the same started happening to the other industries. But when you come to your IT, to the CIO of your company, Chief Information Officer. Again, I'm talking about big enterprises, and they have like a Chief Technology Officer, which is doing slightly different what you think what is being done in a typical startup or technology company. And you come to your CIO, which owns like Chief Information Officer, that owns every like IT aspect, and you ask them, hey, can we develop this app? And they say, okay, here is the compliance you have to fill in, here is the specification you have to provide us with, and your app has to be compliant with that many things, and so on. And it's going to take us 9 months to start, and this is not acceptable at all. So what is happening is those business units, let's say marketing department, saying, okay, we're going to build this app on our own, or like I don't know, some credit department. They said, I'm going to hire some IT engineer. He's going to build this for us quite quickly, this mobile app, and it's going to work. What is happening, unfortunately, is when they build this app, it's not well tested. It contains lots of security issues, first of all, and then there were lots of information breaches from banks like Bank of America and Wells Fargo. But lots of accounts were stolen because of when the chief marketing officer was building the app instead of issuing this to CIO. But the CIO wasn't capable of doing this. That's why in modern times there's a changing role of CIO. So CIO is not some like in his organization like IT is not like, hey, you do all the ideation, you even do some coding around, and you just give this to us. We either will complete this will do actual coding, and will deploy this to the cloud and run it as is, and that's it. And we'll provide you with all the laptops, internet connectivity, which we usually do as a classic IT organization. So not anymore. In order to be successful, you have to involve CIO into the process, the IT. So when you start ideating the product, I mean, you start thinking how it's going to work. So at that moment, you involve the enterprise IT in the creation of it. So you create like a cloud-ready or like modern, very modern product that is oriented on the right personas and many other things. So as you see, it's a different change. It's a change from like a classic supporter mode. It means like whatever you business folks, whatever you tell us to develop, we will develop. To the fact that okay, we are in sync on the same goals. You tell me your problem, and I will tell you what kind of technology might solve it. Again, for most of you who listen to this stream, seems like, well, man, you're telling us very obvious things. But trust me, for the companies that are in the business like 60 or 70 years, and that have been doing some stuff and earning money from their services in 60s, 70s, or even earlier, when there were no computers around, I'm not even talking about clouds, these things are not that obvious. And this is the huge demand now in the market. And not only that the mainframes are dying, that's not even about that. It's because the business is dying. I mean, they are being kicked off the market heavily, and lots of companies in the past history they failed. I mean, the huge companies that were not adopting the changes that correspond to like in modern times, they failed in the history. By the way, I have a stream you can find in my Facebook account where I speak about 10 failures, well-known failures in the business history. The stream is in Ukrainian, but for those who can handle this, of course, you may find it in my profile, the link, and you listen to this on the SoundCloud. Really, 10 best companies, they failed to innovate and failed to create the right product. So that's why, again, at Intellias, we are focused on helping those enterprises, first of all, those companies that are disrupted by the modern world, to close that gap, to close the gap between the IT capabilities and the demand from the business functions. There's a different scenarios we do this. We start from developing the IT strategy, rethinking what business objectives, business goals we have in front of us. Then we adjust the whole strategy for the IT. Then we listen to the business functions, like what their demand is. So we don't pump them lots of compliances standards, like, okay, we should follow ITIL, or let's apply classic agile methodology, or whatever. I mean, which agile is basically means flexible. So I don't know, maybe you cannot force something that is flexible. It's not possible. But anyway, in many cases, there's just old school IT. They like to pump, let's say, users. That's the terminology they use still, with lots of compliances and requirements, and we slow them down, unfortunately. We help to build a strategy that is new one, that is aimed to focus on a very pragmatic approach when we build what is essentially needed. And if you don't know, if you're not familiar basically with what pragmatic approach is when you build the solutions that solve the problem. Again, we speak about problems today that actually confirm three things. They are pervasive. I mean, it's a global problem either for your organization, at least for your organization, or it's like a global on the market. So it's pervasive. That are urgent, means that it's really, really, really needed. And the third thing is there is a willingness to pay, means that people see the ROI, or at least you help them calculate that ROI and you still see them, and that it can pay off. So simply people will to invest and will to pay. So if your business functions Again, from a business point, we're not even talking that much about technology here. If they see that those three aspects are met, only then this will be a very successful corporation. Only then your technology will empower your business functions. And our goal is basically when we build our services, it is in fact the one that helps to align that strategy. Second thing is the overall advisory. So it's not just to like working in the classic consulting way, right? So hey, here is your 60 pages report. Here's your huge like a number of money that you're going to pay for us for this report, and you go, you're on your own. So we care about the execution, we care about the implementation, and like ongoing advisory and guiding the enterprise, the company, through all those steps on the journey towards the success, towards making towards achieving those goals. And one more aspect that is very important that people usually miss the focus is the quick wins. It kind of comes from a startup world, right? So you may prepare your business case and say, okay, we're going to have a break-even point in 24 months. And if you say, like, and this is it, then you fail. Because if you do not show any visible improvement, any visible result, I'm not saying running application, but really some solution to the problem available. Some people call it MVP or something like that, but it's not always this. In a short period of time, which can be a couple months or even like a couple weeks, or in some extreme cases, even a couple days, then you fail. So this is not the strategy, this is just a vision. So if you can demonstrate the quick wins, then you are actually a successful leader. And then especially if you make your commitments. That's what we do focus as well. And so generally, that's the comprehensive view on our approach, and that's how we solve the market problem and the problem of growing gap between IT and the business functions. I'm probably going to mention the word DevOps for the first time in my talk. It's like why and maybe some of you are surprised like why I'm not mentioning this, like why I'm not using so much words like cloud, DevOps, and other stuff. So DevOps is the culture. And this is the approach basically when we involve operations and development and design and engineering, like everything at once. That's a seamless process. Basically what I was talking about for the previous few minutes. And cloud is commodity now. It wasn't like that in the beginning of previous decade. Now we're in the third decade. It's just started a couple of months ago, this 2020, as you know. Not everyone is happy with this third decade as it began, but it is how it is. Then at the beginning of the second decade of 21st century, there was lots of companies where they were in doubt, like going or not going into the clouds, and there were pioneers, and there were just the first companies that were putting like online transactions into the cloud or their data at all. And I remember my talk that I delivered in All About the Cloud in San Francisco in 2012. There was about trust and transparency, and they were just like, no way. But now it's completely different. Now they trust. Now they go there. So you see how things change, and they might change in the future as well. So that's all I have for the moment. So if you have any questions, feel free to ask. But I hope you kind of enjoyed my quick briefing on what we do and how we do it. Thank you.
Thank you very much, Roman. I don't see any questions in YouTube, but as I said to Paul earlier, is that it will be really good if you can join us in Zoom after this meetup, and then most likely people will figure out what kind of questions to ask you. So we are a little bit off the schedule, but that's probably okay. So let's continue. Now it's time for our first fireside chat. Our first expert is going to be Sergey Pugachev from AWS. Expert Hi. Is just understating his experience because he is now a solution architect at AWS. but his resume include big companies like Microsoft, Google, Booking.com, and Intel.
You
So,
don't ever think about it.
So please don't hesitate to ask your question in YouTube chat, and yeah, let's get started. So what does it mean to be an architect in AWS?
Oh, it's a good job, actually. I like it very much because I like our cloud and I help real people. In Ukraine, for example, real companies to pay less, to optimize their architectures. I have like many meetings a day with different companies, from genetic research to banks, and it's fun. I see the industry and it's a good job.
Cool. I'm sure that many of listeners of this stream would actually like to work in AWS. So I'm AWS community hero, and I can tell you for sure that AWS is hiring like crazy. So please go to aws.jobs or amazon.jobs and see for whatever you like. Well, in this part,
yeah, continue.
Yeah, no, go on.
Yeah, I need referral bonuses, so I will refer you if you will ask.
Excellent. So then let's see what you know about architecture, right? Because we actually made a poll before this meetup, and we asked how many years of experience people had, and what kind of topics people want to know about. And we got a few questions from people who asked, like, hey, let's talk about architecture or different applicable solutions. So I was thinking that we can talk about Grammarly. A lot of people who are watching this stream are actually from Ukraine, and they know what is Grammarly.com. And for those who don't know, I can tell that Grammarly is a technology company that developed a digital writing tool using artificial intelligence and natural language processing. So Grammarly was developed in 2009, which is, oh my God, 11 years ago. And it has became actually first Ukrainian unicorn, which means that company was valued significantly, like a lot. And let me take a role. Let's say I want to be, and I want to build a Grammarly killer. I want to build product which is like Grammarly but better. I mean, who doesn't want to do this, right? So I understand that Grammarly consists of client-facing application, which is browser extension, mobile application, plugins to Google Docs, actually to many different places where I can type with errors, right? And I can do this in any place. And initially, it was built using Common Lisp. I guess it has changed a lot during 10 years. So let's talk about how can we build Grammarly from scratch in 2020. Architecture, services, patterns we can use, and why. So the first part is, let's focus on backend, okay? Can you imagine yourself as a solution architect who was asked to design an architecture for the backend services? And just give us some tips. How would you do this? What would you consider? What would you ask your customer? And so on.
Okay, it's a pretty wide question. I want to say, first of all, that people are more important than the technologies. So if you want to build a new Grammarly or new Google or something like this, and that it will be a good competitor, you need to work with right people and have a good processes. For example, at Amazon, we have leadership principles. Google it. If you want to work at Amazon, you need to know these principles. And it's about attitude to work. It's about customer obsession, something like this. So it's very important. If you speak about architecture, we have well-architectured framework. It's a checklist. There are a lot of things that you need to consider when you're building your architecture. Google well-architectured framework. and check whether your architecture fits this or not. And I want to say that there's no such thing like right architecture or wrong architecture. Yeah, there can be something bad or good, but you can choose any language you want. If you want to choose Common Lisp, choose it. If you want to build monolith, it's perfectly okay. If you want to go to these microservices, it's also okay, because you need to know why you choose it. If you choose monolith, you need to have justification, and for the microservices also, you need to understand why you're doing such things. But you can choose whatever you want, actually. Today we have Kubernetes, for example, with Istio. It's very good for microservices, and a lot of people select these technologies, but many people select it because of something like resume-driven development, where they choose technologies that will be good for their resumes, not because they know why they choose it. So read articles about it and think what to choose. And you need to have fun, because you will use these technologies for the following year or many years, and you need to like what you choose. Okay, if you chose something and you know why you did it, the next step will be to understand what is your focus. What is the core value of your product? What you do? What is the best? What you can do the best? For example, for Grammarly, they can analyze grammatics and texts, and they can build this great engine for helping people to write correct text in English, and it's a competitive advantage. So don't focus on infrastructure. Don't focus on things like building your own orchestration tool because Kubernetes is not good enough for you. Focus on what's your competitive advantage. For example, at AWS, there are a lot of managed service. You can get Kubernetes in few clicks. It's EKS, Elastic Kubernetes Service. Like in 15 minutes or 20 minutes, you will have Kubernetes, and you don't need to manage it. Somebody will manage it for you, and you can write your own code. If you use function as a service like Lambda, it's even easier. You don't need to care about operating systems, software updates, boring stuff. You can focus on what is important for your project. So serverless may be a good idea for such a startup, because you need to be fast. You need to deliver results as fast as possible. And if you will try to build infrastructure by yourself, it will be very hard to have a pace you need. You want to ask something?
I think I just want to focus on few things here. So you say that you can pick up pretty much anything what you're comfortable with, and I'm honestly liking the idea that we should have fun. Well, that's pretty much everything what I do at work. But serverless for me seems the most essential part, because you focus on just your product, right?
Yes.
But what about costs, and maybe you can talk about how expensive can it be or how cheap it is. And in particular, I'm representing like a customer. I want to say that, hey, people are writing with errors steadily. Like the load is significant. People are producing fixed amount of errors per hour, which means that we don't have to think about spikes and anything like that. Does it mean that we don't have to use auto-scaling, or is there any downside of using auto-scaling even?
So, for example, if we talk about auto-scaling, that's important, because usually you can't predict spikes. Maybe some popular blogger posts on Instagram something very good about your service, and in the next hour you will have like thousands of visitors. You can't predict it really. and you need to choose technologies that will provide you insurance for these events. If you have your own service in your own data center, you can scale it all. If you use, for example, I don't know, just one virtual machine or several virtual machines without any auto-scaling and something like this, you can adopt fast enough. And for example, when we use Lambda and function as a service and we go completely serverless, we don't need to think about auto-scaling. Somebody did it for us. And because of this, I like Lambda. We have auto-scaling in Kubernetes. For example, we have new service like Kubernetes for EKS, Kubernetes and AWS called Fargate. It's completely serverless Kubernetes. And it's almost infinitely auto-scaled. So you just say, okay, I need like 10 pods in my Kubernetes, and they will run somewhere. You don't need to care about actual servers. And yeah, and you can, and if you have 10 times more visitors, just ask Fargate to run 10 times more pods. It's so simple. That's one of the reasons why I like cloud so much, because it's easier to solve these obvious challenges. And my advice will be to go serverless as possible, because really you don't need service. You don't need to have your own electricity provider, for example. You don't need to build your own nuclear power plant near your office to have your electricity, and you don't need to care about your service. It's not your job. Your job is to create value for customer, and customers don't care about which virtual machines you have, which physical service you have. You need to provide value for customers. And in the cloud, all your competitors have the same virtual machines, have the same databases, have the same stuff. And if you will try to build everything by yourself, you just will lose this competition. It's that simple. Write code that will bring value for customers. So serverless is
I think most of attendees of this meetup already understand the benefits of cloud, and usually people look at this from the best side, like you don't have to build it, you can use managed servers, you can focus on your business value, and so on. It usually comes at a cost, either small cost or uncontrollable cost. And can you talk about some cost-saving options on AWS, which you think people should be looking more or maybe using more?
Yeah, that's a crucial part, because it's not easy, to be honest. To control costs on AWS and on the cloud especially, it's pretty hard. You should spend time on cost optimization. You can't just spin up few virtual machines or just few lambdas and expect that it will be cost optimal. No, you need to spend time on cost optimization. So, for example, there are multiple types of virtual machines. If you need to have virtual machines on Kubernetes cluster, for example, you can choose between compute optimized, memory optimized virtual machines, GPU optimized virtual machines, a lot of stuff. But for example, we have T instances that are burstable and C instances that are compute optimal. If you have workload that is, if you have small workload, for example, that can if you have small workload and there will be some spikes in it, but usually you don't load your CPUs with 100%. It makes sense to choose cheaper virtual machines, but burstable ones. If you have spikes, yeah. So there are a lot of different types of virtual machines. You can see that price in different regions are different. For example, you can open a prices in a region that is close to UNC that they are higher than in some other region. Maybe if you have like data processing tasks that are very heavy and you need to spend a lot of compute power for this task, maybe it makes sense to do it in a cheapest region. Yeah, data transfer will also cost some money, but you need to be careful which region you choose, which type of virtual machines. For example, AMD virtual machines are cheaper than Intel virtual machines. Why you choose Intel virtual machines over AMD? Because you get used to it. You always did it. We have ARM virtual machines. ARM processors are also good and cheaper, and maybe you should consider using ARM instead of AMD and Intel. We have saving plans. If you have database that you for sure will work for following year, you can use cost saving plans and have a commitment for the year and save a lot of money with this commitment, like 40%, for example. And we have spot instances. There are type of instances that you can save up to 80% of a regular price. But these instances can be stopped by AWS at any point of time. But it doesn't matter. If you have auto-scaling group and you have a lot of, for example, web services, and you run something on the spot instances, you will just save 80% of costs by just using spot instances. And you need to write a small piece of code to figure out in which moment to spin up new instances and how to deal with it. There are a lot of options to do cost optimizations in the cloud that was not available on premises, and that was you need to learn how to do it. Because, for example, for machine learning tasks, I see a lot of customers who come to who use something like Kubeflow and Kubernetes for machine learning in their own data centers. They come to the cloud, they spin up Kubernetes, they spin up everything that they had in the local data center, and it will cost them like, I don't know, $500 a month. But we have different services. We have SageMaker. With SageMaker, it's possible to set up clusters automatically and don't manage clusters. There are no upfront payments and so on. And it's possible to do the same with like dozens of like $20, $30, or $50 per month that was done on premises with Kubernetes. Yeah, and $500. I speak about machine learning tasks. I work a lot of machine learning, but there are different types of services that can save money, and there are a lot of helpers like cost optimization. Yeah, but my point is that it's a job. It's not like you are a developer or DevOps and you did well on premises, you can just move everything to the cloud and you will have something much better. Of course, you will have something much better, but you need to spend time on cost optimization. It's like dedicate a few hours a week for cost optimization. See the reports, and there are a lot of options that was not available on premises.
Yeah, exactly. So as I'd like to say is that normally there is a full-time job for somebody to watch out AWS release notes to see every day what kind of services has been released and how they can decommission some of the in-house infrastructure, because, hey, AWS has just released this service, so we can delete our own. In my case, I remember we have been working on Elasticsearch cluster, and we were so happy that we finally made it until AWS released much better offering in a few weeks after we finish. So this was pretty disappointing. And this was not the only case when I have been in this situation. Well, we actually have a few questions from the audience. Okay. So Sergey is asking, what about cold starts of serverless function and real-time microservices with usage like gRPC or WebSockets? Can you talk about that?
Yes, that was the issue because Lambda didn't support. There was the issues in Lambda with cold start, but a few months ago we released new option to have I don't remember the name of this feature. So now you can have. Do you remember?
Elastic interface?
No. We can have few lambdas that is available all the time, and you don't need to care about this cold start problem because few lambdas will be available for you if you want to pay for it, because you can have this check mark now and say, okay, I want to pay a little bit more, but have lambdas that will be available instantly. And yes, so now it's solved, but you need to pay it. It's trade-off. It's always a trade-off in the cloud. You will pay more, but have some features. And what was the second part of the question?
The second part was about real-time microservices with usage like gRPC or WebSockets.
gRPC and WebSockets, yeah. It's if you need to build such service, I think there are not only one option, because at AWS we have a very good approach that we have more than one service that can solve any problem. Because we provide, for example, if we speak about something like, I don't know, Kafka, we have managed Kafka, we have Kinesis, we have different services that do the same job. And for the compute, we have a lot of options. For example, we have Beanstalk, it's a good service. We have Lambda, we have managed Kubernetes. And for this option, if you want to build something in real time, some real-time service, I would suggest to go to Docker and Docker containers. So the next question is where to run them. If you need the cheapest option and the fastest option and serverless option, you can choose Elastic Container Service, ECS. It's the option to run Docker containers in the cloud. It's much simpler than Kubernetes. You can run it with Fargate in the serverless mode. You don't need to care about service at all, and you can just run as many Docker containers you need. ECS, Elastic Container Service, don't have all the features of Kubernetes. If you're a big company and have a lot of services, maybe it makes sense to launch Kubernetes. But if you need to just run a couple of containers, like few services, you can just do this task with ECS. It's simple. You can run it. It's serverless in serverless mode, and it's very much like Lambda, to be honest. But it's with Docker.
Right, and Anton Shah mentioned that this is called provision concurrency, and it was released December 2019 during reInvent. Right. And there is actually a relevant question from Anton about Lambda cost. Anton,
can I mention, we released provision concurrency is a very good feature, and a few weeks ago we released an option to have EFS disks attached to Lambda, and it's a very interesting option. So there are a lot of new stuff in Lambdas. Okay, so next question about costs.
Yeah, Anton asked about Lambda costs. So he said that we have to use provision concurrency, and this is not so cheap. EC2 is cheaper. What can you advise if we want to stay on Lambda? Well, I completely understand you, Anton. I'm also in the same position sometimes.
EC2 is cheaper, use EC2. I don't think that, I think that in some cases Lambda is cheaper, and in some cases EC2 can be cheaper. But think about time that you need to spend on managing these EC2 instances, on installing updates, on configuration stuff. Your time is not free also. If you can, for example, a good software developer has pretty high salary. Many of us work in this industry because of this. And if you will save, like, I don't know, days and weeks of your developer time and spend a little bit more on, I don't know, on Lambda, it makes sense. But there are not one option. If you think that Lambda is with provisioning concurrency is not as cheap as you want, try ECS. That's the following option: be a little bit less serverless with ECS, but have more. But use Docker and be serverless. Like, yeah, you can choose Beanstalk, ECS, Lambda. It's not a, usually people think that it's Lambda or EC2 instances that you need to manage manually. No, there are a lot of options, less serverless or more serverless. Try ECS.
Yeah, that's pretty good advice. That take a look at all available options, and I'm sure that somebody will release even more options. Well, I have another question, which is if we are looking into or like talking about AWS and your expertise when you talk to customers, can you tell us what is the most underrated AWS service startups need to use, and why do you think so?
It's very hard to answer this question because different startups need different services. Almost every company, startup or enterprise, needs something like S3. They need to store data. Almost any company use Lambda, actually. Almost any company use virtual machines. But there are a lot of small services that can really help. For example, for machine learning, it's SageMaker. It's my favorite service. If you need to, do something like, I don't know, if you need to build your robot, we have RoboMaker. If you need to connect to the satellites, we have service for this purpose. We have a lot of services for every purpose, every task you have. And it doesn't. We don't want everybody to use every service. It doesn't work this way. But we have, for example, QLDB, Quantum Ledger Database. If you need to have a secure database for protected transactions or something like this, use this product. We have graph databases, Neptune. We have so many different services. We have IoT services. There are so many different services that are available and can help you, but you don't know about this. Just open the list of services, see what we have, and maybe there is something that you need, but you didn't know about it. Yeah, and use SageMaker if you need to do machine learning. It's my favorite service.
Yeah, when you say that open list of all services and just by name try to figure out what does it do, well, I think this person will have bad time figuring out by name for all of these services. But if you pass this challenge, then what I recommend to you do next is that you can guess by icon what does this icon mean. Well, it's a little bit challenging.
Yeah, that's true. Icons are also helpful. For example, I want to say that we have a lot of capabilities that you know about. For example, we have S3. We can store files on S3, but not many people know that it's possible to do SQL queries to CSV files and Parquet files that are stored on S3. You can just do S3 select and run SQL queries against not a database, but against your file storage. And there's so many such good features that people don't know about. And part of my job just to tell people which service they can use, because you mentioned about the full-time job to monitor all the news and updates. It's my job. And people come to me and ask, what can we use? And I say, you can use this service. Oh, we didn't know about it. Now you know, and you can use it. It's part of my job. It's to remember everything. Yeah.
When you mentioned that you can search inside of content of file, this is called S3 Select. I was so happy when I discovered it and when I was thinking to use it, but then I discovered that, hey, there is actually a limit of 256 megabytes, and I was disappointed because my file was 1 gigabyte.
We have Athena for this purpose. It's also serverless service. And if you have really huge files like terabytes, we have Redshift Spectrum for this. So we have not one service, but 3 services for this purpose. And it depends on the size of your data, which service to choose.
Right. And by the way, there was a question by someone about Redshift, which we don't have time to go through right now. So please, if you have any other remaining questions, please join our Zoom, which we will have after. I have the very last question, which I want to ask you. And this is actually not a question, but more like a proposal or a request. Do you have any final comments for the audience?
Oh, I don't know. Yeah,
Eat healthy and call your mom, no?
Have fun. Yeah, call your mom. It's important. I will call my mom today after this talk, obviously. And yeah, really, life is too short to use boring technologies. Use what you really like.
Cool. Thanks for that, Sergey. And now it's time to move on. So there was supposed to be a break, but well, we will not have any break. So stay tuned and please join our community in Telegram channel, as well as this YouTube channel, where we will publish more videos like that. And be ready to welcome another fireside chat. So let's continue our fireside chat. Now I'm glad to welcome a person who lives extremely close to me right now. He's also from Norway, and well, I don't know even where to start, but let's start with a quite obvious thing. Let's start with the introduction. So Shailendra Singh Chauhan, hopefully I pronounce it correctly, or more or less correctly. He works as a global cloud solution architect at Microsoft. And it is absolutely honored to have you here and learn from you, because I'm sure that your solid experience working in a bunch of different companies and industries will be really valuable for most of us. In particular, your recent and most active interest in cloud native is something what a lot of people are after. So welcome. Can you tell us a little bit about yourself?
Okay. So first of all, thank you everyone for joining us in these late hours. So I know that we have not taken any breaks, so apologies for that. My name is Shailendra. I work as a cloud solution architect in Microsoft for global partners. And I am recently building a lot of solutions with them, mostly cloud native solutions. And yeah, that's what I would like to spend my most of the time going forward.
Cool. Let's start with, hey, what does it mean to be an architect at your role?
Actually, it's a very good question. So, when I started my career way back in 2003, somehow at that time, these people who were architects, they were seen as the stars. So, I always have aspirations to become an architect. So, yeah, I was always inclined towards being an architect and into software architecture. And then, now and then I was part of architecture. I would not say that I was always like a full-time architect, as I am from 2016. So 2016, I'm working as a full-time cloud solution architect in Microsoft. I would say that, every day is learning. Every day I do mistakes. And it's the mistakes or, not taking the right decision which gave me the most insights. But yes, I do take right decisions also. Time has changed a lot since a few days back, if you see Azure, I mean the cloud, I mean the offering from Microsoft, it has evolved a lot. So that is also a challenge for me as a single person to almost know everything, like 350 plus services in Azure. So I would say that job of an architect is difficult, because modern day architects are supposed to be hands-on also. Gone the days when you just need to design and just disappear. Now, as an architect, you need to understand the technology, you need to really understand the business, you need to be very good in understanding the business or the domain, and then you need to be part of the implementation. And the architecture what you need to make, that needs to stand for a few years and also keep on changing, or I would say evolving.
Right. So you are talking about good architects. Okay.
You know what? That's a dream, I want to
Right.
become the
Right.
perfect architect, but with the definition of time changing, a few years back, cloud was introduced. Now cloud is there, going to stay for ages. I think this role or this profession of architect will keep on evolving. The challenge is not that it's going to evolve. The challenge is to, go with the change and adopt for new technologies or mindset, not just cloud native, but DevOps or serverless. So these things are challenging. And I would say
Well,
that,
yeah. No, since you mentioned so cool words in one sentence, I cannot resist to ask this. So, what are you working on these days?
so mostly I'm working with my partners and their end customers to build application on cloud. A few days back, it was mostly migrating existing application from on-prem to the cloud, or to the hybrid cloud. But these days, from last 6 7 months, I'm working mostly on building cloud native applications.
Wow, that sounds interesting. Well, let's talk about something controversial. You work in Microsoft, and I have T-shirt of another company, which is absolutely not related to what we're talking here. But I was thinking, like, now again, it's 2020, it's summer, it's June or almost July. It's very warm, it's very good weather outside. So, how would you build Amazon.com e-commerce website in 2020 using Azure services? Let's talk about this. Okay, you mentioned
Mm.
cloud native. Can you explain what is it, why it is important, and well, can we use cloud native technologies to build Amazon.com?
Mm-hmm. So I think I will start with your last question first. That let's first try to define or understand what is cloud native. So cloud native is the new way or new approach of building application or architecture or platforms to take the benefits of the cloud. So for me, the biggest benefit cloud bring for is scalability and resiliency, of course with cost benefits. So if I would like to utilize these benefits of cloud, I need to come up with the new way of building application, and that approach of building new application is the cloud native approach. Now cloud native approach, if you define, like if you try to describe it, a cloud native describes any application, architecture, platform, and processes which help you to deliver application faster and in a way help you to respond to the changing user needs and the business requirements. I will try to simplify the definition. Cloud native in simple words is application code and dependency packaged as containers, deployed as microservices, and exposed as APIs. And this pretty much process can be managed by DevOps process and tools. So like service meshes or other things, they basically are example of this thing. Containers, service meshes, orchestrators, they all are example of this cloud native ecosystem. Now going
Right.
um, now going back to the definition, I told you that one of the very important pillar of cloud native application is this microservices architecture. Microservices architecture is an architectural approach where you build a system or a software by combining a number of services. These services are very much independent from each other, and they are talking to each other on well-defined interfaces. Now, when you build system in this way, each service can use different technology stacks. So I can use Go for one service, I can use React for another service, I can use .NET, you just name it. So in this way, what I can do is that I can model my services around the business domain I'm working for. And these services can be very much independently deployable and scalable. If you remember, Paul has mentioned this very well, that the architecture of the application shows what is the structure of your organization, and the modern structure is that you make these small teams in every company. Like when I will talk about like how to build a site like Amazon.com on Azure, you will build that kind of website with like a I would say, like, let me just take the picture over here. So when you build an e-commerce application, you have this front end service where your users are making requests, then you have this cart service, you have payment service, you have shipping service. So you have built this e-commerce system like Amazon.com with different services. And now in my organization, the one who is building this, I can dedicate different teams for building these individual services. The contract or the interfaces between these services are well defined. So these teams can work in parallel and they can deploy number of times independent of other services. So in this way, I'm agile. I'm delivering the services very fast, maybe 100 or 200 or even 1,000 times in a week to my end users.
Right. Okay. If we focus on architecture, well, now it's 2020. It's good weather outside. Everything should go serverless, right? No, or maybe monolith. No, monolith is too bad. Monolith is for bad mood, right?
Well, you have to understand. I have heard this lot from so many days that we call layered architecture as monolith, and I understand because monolith is like one of the prime differentiator is that a monolith is deployed as a single unit, scale as a single unit. But when I started my career in 2003, I remember every job interview I went, they asked me about this n-layer architecture or n-tier architecture. And at that time, people thought that n-layer architecture is the silver bullet. Same for microservices. Right now, we think that no matter what kind of application we are building, let's use microservices architecture. Well, no, that's not really true. It is all depend on what kind of application you're building. And of course, microservices is very good architecture, but building microservices architecture is not right now a very easy thing. If you ask people like me, who have spent most of their life building layered architecture, we used a lot of time to transit from that layered approach to monolith, this new microservice approach. And microservice approach in itself is not going to alone make you successful. You need to combine it with containers, APIs, and DevOps to fully utilize the benefits of cloud native and the cloud. So we are calling this a layered architecture monolith just to say that microservices are better. But when you go for a solution, like I think Sergey mentioned it very well, that instead of starting with selecting the services and building a solution, you should start the other way around. That start with the business problem, design a solution, and see that to build this solution, what kind of architecture you can use. Of course, in 2020, like e-commerce website or a site like Twitter or Netflix, microservices more sense, but still, layered architecture is still relevant. I can give you an example. People are very good in making microservices, but there are few people who still do not know much about microservices. And if they are making a very small service, let's suppose I'm making a very small service about this event, I'm not going to choose microservices architecture because it will take a lot of time. I will definitely just go for that layered architecture because it's just simple and easy to create. Of course, not very scalable and not very enterprise scales or bigger one, but yes, that will also solve my purpose. On the other hand, any enterprise application should be first considered, should pass through this evaluation process, that whether microservices makes sense or not.
Right. And if we're talking about Azure, and Azure, you mentioned, has 300 something services, which to me sounds insane. It's just a lot. It's just a lot. And what if we want to build Amazon.com e-commerce website? Are there enough Azure services to do this? Can you tell about what kind of magic service we can use to make such big website? I don't want you to mention all of these services, of course, but if you can just highlight most key services, it would be pretty interesting to know.
So as I said you before, in the previous question is that I'm going to choose microservices architecture for building this e-commerce application. And then for this e-commerce application, I will need some functionalities like identity and access management. So, based on my needs, I would say that I need for sure like something like Azure AD. Then I'm going to build a microservices application. Now, once I have developed this application by using tools like Visual Studio Code, or you name any editor, and then using Azure DevOps, and lately also GitHub Actions. Now I need to choose a platform where I can deploy my microservices application, this distributed application. So I have two choices. In terms of choosing this platform, which supports microservices and containers. The first is Azure Kubernetes Service, the managed Kubernetes service on Azure. Second option is Service Fabric. Service Fabric is the secret sauce on which Azure is built. It's the same orchestrator as Kubernetes. Few differences, but equally capable and same powerful. But looking around, AKS or Kubernetes and the ecosystem, I will go for AKS first, because AKS has very good integration with other services as like Azure AD, Azure Functions, because you mentioned it also in a few minutes back that microservices together with serverless like Azure Functions would be a very good combination. And now also the world is moving towards more like event-driven architecture, where your microservices application, different part of the application are event-driven. I mean, they are not always up and running. They will respond to the event. And that's where AKS or Service Fabric, they both have a very good system. Given the support from open source community, I would first to go for AKS, because you have to understand, I also have to find skillful people to work on this project. And as I can see that right now, you will find a lot of people who knows Kubernetes very well. So yeah, that is also one of the important decision to make while choosing the platform. So Azure AD, Azure Functions, Azure Kubernetes Service, and then you have other services like Key Vault, because I need to be very secure when I run these kind of e-commerce application. Cloud in such, Azure Cloud is providing you all sort of mechanism for resiliency. And then because if I'm going to make a globally distributed application, I would like to host this application in different regions. So I'm going to deploy different managed clusters in different regions. And then the final and the most important piece of this application is the storage or persistence. So I need to choose a service where it provides, if I go for a distributed application, globally distributed application, which provides me globally distributed storage and also like multi-model. So I will go for a service like Azure Cosmos DB. Azure Cosmos DB is a globally distributed multi-model database as a service, and right now one of the fastest growing database services on Azure.
Cool. Well, we have a few questions from the audience actually related to what you just mentioned. So Sergey is asking, what has happened to Azure Service Fabric? It looks like Kubernetes and serverless killed it.
Actually, that's my favorite question. That's my number one favorite question. The answer is no. Azure Service Fabric is going to live till infinity and beyond, as long as Azure is living. As I told you, Azure Service Fabric is the service which is running the entire Azure cloud. So Azure Cosmos DB is a service built on a service fabric. I would say
Right.
that Kubernetes was developed in Google, Azure Service Fabric was developed in Microsoft. I think Microsoft, it's my personal perspective. Microsoft was a little bit late in announcing about Service Fabric, but it's equally capable service. It's still into production and it is still being developed. It's going to stay there for a long time.
Cool.
But as
Um,
Azure is the platform for all the developers, we also decided to invest in Kubernetes. And by the way, one of the creator of Kubernetes, Brandon Burns, he works in Microsoft, and he's heading the organization which works both with AKS and Service Fabric. So Service Fabric is still there. And by the way, before I started working with Kubernetes, I was working a lot with Service Fabric.
Cool. I'd like to ask you to answer a little bit shorter because we have a lot of questions. So the next question is Paul is saying that I have seen people say that startups build monolith until you need the scalability of microservices. Do you agree or disagree with that?
Actually, in a way, yes, I agree with that. So, like, let's suppose I'm starting my startup, and actually not now, in 2016, when I was not very good in distributed systems or microservices. At that time, I was very good in building layered architecture, which you are calling monoliths. I would have made it very fast. But then when I came to know about the distributed systems, the problem of scalability and independent deployability, I started to look at microservices architecture. So, it also depends at what cycle you are in and how much comfortable you are. So the new folks coming in the industry, I sometimes feel jealous with them that they are not working on this layered architecture or these things. I spoke to few, people who are right now in college and soon going to finish their degrees. Actually, they are working on distributed systems like microservices. So if you ask them, yes, they will choose the microservices from they first.
Yeah, exactly. That's because they live only in this year. They didn't know what happened before. Well, another question is, what would you use for communication in e-commerce product built on microservices? Service bus, event hubs, event grids?
I think these products, what you have mentioned, like service bus, event hub, event grids, they are similar. They have overlapping functions, but one cannot replace other. Service, there is a limit. When you have to build like an event-driven architecture, event grid is the way to go forward. Pops up scenario in this. Event hubs are actually for ingesting large amount of data. Event hub is for like IoT scenarios where you're ingesting a lot of data from the field. And then service bus is for the same enterprise service bus scenario. So I would say that one cannot replace others. It depends on what use you are going to do. But for communication between microservices, I would say that start looking into something known as gRPC. And Azure has, or actually not Azure, but like programming model or frameworks like .NET Core and ASP.NET Core, they have very good support for gRPC. It depends whether you are going to create a mesh kind of system or you want to use like, the service oriented architecture where you use a common service bus for messaging.
Right. Our friend Maxim say hi to you. Hello, Maxim.
Hi.
And he's asking, what is DARP and how does it help with building cloud-native applications?
Okay, so thanks for that question, Maxim. Dapper, or actually distributed application runtime, is an event-driven programming model or framework for building microservices application. So we are talking a lot about microservices application. When you look into these microservices application, you will see that there are some common challenges or common needs of all the microservices application like pub sub, state management, and more. So if we start building those things into each and every application, that's a waste of time. So what does Dapper do for you is that it has taken these best practices, and it has codified those building blocks for you, like state management, PubSub, you name it. And so when I will start building a microservices application, I will use something like Dapper to get quickly up and running. So if you check the documentation which I have posted on the YouTube channel, look at this thing. This is something started with Azure Incubations team together with the community. So this is not a product developed just by Microsoft. This is something developed together with the community. It works very well with orchestrator like Kubernetes, and there are plans to port it on any cloud or any edge device. So if you are building any IoT solution, look for Dapper. It will solve a lot of problems for you. The best thing about Dapper is that it works on a sidecar architecture. And then whenever I need some functionality like state management or PubSub, all I will be doing is that I will be doing a local host call, and I'm done. And yes, this will make your port very much portable across the clouds and across different environments like cloud or edge.
Cool. I'm glad that I learned something new myself today because I had not heard about Dapper like never.
And by the way, it works for any language and any framework. It works for Java. Because it's just Dapper is you access the functionality of Dapper on standard HTTP or gRPC API. It can work with any language, any framework. We are adding more frameworks to it, like SDKs. We have .NET, Java, JavaScript, Go SDK. So you have a very good starting point.
Cool. Well, we have a few questions more. So let's talk about industry right now. And you are talking to many of your clients on a daily basis, and you see them use different Azure services. And what is, in your opinion, the most underrated Azure service, which startups in particular don't know about, but they should? Please be not so. Try to answer short because we are a little bit out of time.
I think that whenever the startups are starting, I would suggest that look for different kind of compute options like virtual machines or Azure functions you get, and also like storage models like Azure Cosmos DB. There is a free tier for Azure Cosmos DB, and most of the services like basic networking is free on Azure. This is what we are talking about, the services. But check for two links. I'm going to post it over here. Is that there are programs also from Microsoft, like Microsoft for Startups. One I have posted over here, and Azure for Startups. So not only Microsoft is providing services, cloud services to help these startups, but they are also providing programs. So look for these programs, and I'm sure that you might find something very useful over there.
I don't see where you post these links.
I'm actually posting it on the YouTube channel.
Well, I don't see anything there from you.
Actually, okay. So look for search internet for two things: Microsoft for Startups and Azure for Startups. Actually, Azure for Startup is part of Microsoft for Startups. I see here a lot in Oslo when I see that events are happening for startups, for entrepreneurs.
I see. Cool. Next question, which is actually a pre-last question, is what would you suggest for all developers and architects to learn?
Actually, it's a very good question. So if I go by my personal experience, I would say that I wish I would have started with the containers and orchestrator, not in 2016. I wish I would have started way back when it was in 2014, 2015. So I would say that, look for these four parts of cloud native, like microservices and containers, DevOps and APIs. Very important four things to focus for future. And then in my time where I come from, it was it was okay to just learn one language like C#, but now not anymore. My plan is to learn at least two more languages, which Maxim is going to help me. One is Node.js and Go. So don't just
Cool.
rely on one language. Learn more than one, actually. At least go for two or three. And enjoy learning.
Cool.
That's all. We all do mistakes. So mistakes are the something which teaches us a lot.
Cool. Well, do you have any final comments for the audience?
I think the final comment is that we heard a lot of people in all different perspectives. I would say that the time has changed, especially we have some tough times ahead of us. We need to change the strategy because we have only 24 hours in a day. So make use best use of your time. Spend it on learning something very important, which is good for your company and for yourself. And yeah, have your learning shoes always on.
Cool. That's really good advice for people who are sitting in quarantine and has nothing to do. So yeah, go and learn something. Thank you very much, Shailendra. And with that, we are 25 minutes past the schedule, but I guess nobody mind. So thanks everyone for attending. Thanks all attendees, organizers, Intellias for providing this platform to all of us. Now I'd like to invite everyone to Zoom after party. You can find link in the description to YouTube video, and there will be a link to feedback because, as you understand, we want to make it better next time, and your feedback is really highly appreciated. Inside of
Thanks,
Zoom, we
Anton,
can
and
talk
thanks
about...
everyone.
Thanks. Bye. Okay. See everyone in Zoom.